5 Impressive Ways AI Impacts Software Testing. 1. Improves Object Application Categorization. AI is widely used in object application categorization. When tools and testers are created, unique pre-trained controls can be created. Once the hierarchy of the controls is categorized, testers can create a technical map to obtain labels for the different controls. In the near future, AI will become capable of observing users perform exploratory testing on the testing site. And once user behavior is assessed, it can assign, monitor, and categorize the risk preference. 5 Impressive Ways AI Impacts Software Testing. 2. Automation of test case writing. Gone are the days of web crawlers. As automation is picking momentum, AI tools have become capable of learning business usage scenarios of test applications. They can automatically collect insightful data such as HTML pages, screenshots and page loading time, and eventually train Milliliter's model for expected patterns of the app. And as soon as they are executed, any variations are marked as potential issues. This makes it easier for the tester to find and validate differences and fix issues. 5 Impressive Ways AI Impacts Software Testing. 3. Enhanced Accuracy. To date, source analysis requires human resources to accomplish the task. Unfortunately, because of the enormity of the data, even the best experts could overlook or miss out on observing certain critical defects. Human error and the tendency to lose focus further impairs the experts involved in software testing. It can be disastrous if bugs caused by these errors are caught by consumers before project stakeholders. Product positioning and brand reputation can be jeopardized. Five Impressive Ways AI Impacts Software Testing. 3. Enhanced Accuracy. Thankfully, AI can't teach systems to learn source analysis and, in the future, apply this acquired knowledge. This ensures that testers have greatly enhanced accuracy. It eliminates the probability of human error and also shortens the time to run a test and increases the possibility of finding defects or bugs. 5 Impressive Ways AI Impacts Software Testing. 4. Automation without the user interface. AI-based techniques can be applied for non-functional tests such as performance, security and unit integration. It can also be applied on various application logs, which assists in developing auto-scaling capabilities such as bug prediction. 5 Impressive Ways AI Impacts Software Testing. 4. Automation without the user interface. AI algorithms can enhance UI testing, predict the next test, determine the outcomes for subjective and complex tests, and much more. In other words, AI could increase the overall test coverage while it increases the depth and scope of the test itself. Five Impressive Ways AI Impacts Software Testing. 5. Reduces cost and decreases time to market. The need for manually repeating the test is time-consuming and extremely expensive. But with AI, such tests can be automated to repeat several times over. Each time the software test is repeated automatically, the source code gets modified to correct any bugs. This eliminates the additional cost of repeating the test and increases the speed of the test from days to hours, which in turn saves more money. Milliliter Testing Workflow. Milliliter testing workflow is about how to conduct milliliter testing with different testing activities. In this section, we first briefly introduce a role of milliliter testing when building milliliter models, then present the key procedures and activities in milliliter testing. Role of testing in milliliter development. The life cycle of deploying a machine learning system with milliliter testing activities involved. At the very beginning, The prototype model is generated based on historical data. Before deploying the model online, one needs to conduct offline testing, such as cross-validation, to make sure that the model meets the required conditions. After deployment, the model makes predictions, yielding new data that can be analyzed via online testing to evaluate how the model interacts with user behaviors. Role of testing in milliliter development. There are several reasons that make online testing essential. First, offline testing usually relies on test data, while test data usually fails to fully represent future data. Second, offline testing is not able to test some circumstances that may be problematic in real applied scenarios, such as data loss and call delays. In addition, offline testing has no access to some business metrics such as open rate, reading time, and click-through rate. Role of testing in milliliter development. Data validation is an essential requirement to ensure the reliability and quality of machine learning-based software systems. However, an exhaustive validation of all data federal to these systems, i.e. up to several thousand features, is practically unfeasible. In addition, there has been little discussion about methods that support software engineers of such systems in determining how thorough to validate each feature, i.e. data validation rigor. Therefore, this paper presents a conceptual data validation approach that prioritizes features based on their estimated risk of poor data quality. Role of testing in milliliter development. The risk of poor data quality is determined by the probability that a feature is of low data quality and the impact of this low data quality feature on the result of the machine learning model. Three criteria are presented to estimate the probability of low data quality: data source quality, data smells, data pipeline quality. Role of testing in milliliter development. To determine the impact of low data quality features, the importance of features according to the performance of the machine learning model, i.e. feature importance, is utilized. The presented approach provides decision support, i.e. data validation prioritization and rigor for software engineers during the implementation of data validation techniques in the course of deploying a trained machine learning model and its software stack.